Module 5, Part 4 is solving rational equations. There's one objective in this module, and it's to solve rational equations by getting rid of denominators. So your goal is to consider is factoring again. If anything is in the denominator that needs to be factored, that is your first step. And then from the factored form, determine a least common denominator from all the factors in the denominator. That's going to be the new learning in this process. I've laid out the steps on the right hand side here, and I've put them into two parts. The part 1 contains the new learning, and the part 1 is going to get something like example 1 here. If you notice, this is a rational equation because it has numerators and denominators. So the goal of part 1 is to get rid of all of the denominators, to cancel them out, okay? And so you're familiar with something like x plus 3 plus 2 equals x minus 5. Something like that, right? That's just a linear equation. You can solve that. That's from 8th, 9th grade, Algebra 1 type things. And so the goal and the way you can check your work is at the end of step 2b, it should have no more denominators. The rational expression should just go to a linear equation. All right, so just be aware of that as I'm doing this process. And so step 1 is to rewrite denominators in factored form if necessary, and then state the excluded values from factored form. So again, I need to analyze the denominators, in this case, the basement, and see is there any pieces that need to be factored. The x minus 4 on the left-hand side of the equation and on the right already look like they are factored. And what I'm looking at is I see a rational expression here, here, and here. So there's 3 pieces in this equation. I noticed that the bottom of the middle piece, so I can label these 1, 2, and 3. The bottom of the second piece needs to be factored. And it is a quadratic trinomial, so I know I can factor it with MAC/AB. In order to do that, MAC is my 20, AB is -9, and I find factors of 20 that add up to -9. 1 and 20 don't work. Go down to 2, 2 and 10. 2 times 10 is 20, but no combination of that would add up to -9. 3 isn't a factor. And 4. 4 times 5 is 20, but I need it to add up to -9. So I need to make both of these negative. -4 times -5 is still a positive 20. -4 plus -5 is -9. So now I have my factors, and so now I rewrite. Step 1 is to rewrite denominators in factored form if necessary. And so I'm going to drop down my first piece because I didn't touch that. 4 over x minus 4 equals, and leave some space, kind of like what I'm doing in between your pieces, because we're going to multiply by a least common denominator in just a second. So equals 3 over my factors now. I have an x minus 4 from this factor, and an x minus 5 from this one. Now, instead of x squared minus 9x plus 20, it's written in factored form, x minus 4, x minus 5. And then finally, plus my third piece I did not touch, so I'm just going to rewrite, is 1 over x minus 4. I'm almost done with step 1, and from the finalized step 1, I have to state the excluded values. And so the excluded values, again, you have to look and consider how many factors exist in the denominator, and factors have a variable. So right now I see 1, 2, 3, 4 different factors, or 4 factors I should say. But if you notice, there's 3 factors that are the same, x minus 4. And so I only have to say x can't equal 4 one time, because if I put 4 into this factor, it would be 0, this factor, it would be 0, and this factor would be 0. So if factors show up more than once, you only have to state the excluded value for that factor one time. But there is a different factor over here, x minus 5, so x can't equal 5 here either. So at this point, after I've stated the excluded values, I am done with step 1. Moving on to step 2a, or part 2a. 2a is the new learning, but it's pretty simple. You just determine what's called the least common denominator out of all the pieces in the denominator. So again, I've already counted that there's 1, 2, 3, 4 pieces. And from there, I have to consider what is in common and what's not in common. And I have to include everything that exists there, everything that shows up. But if it shows up more than once, I only have to write it one time. So if you notice, x minus 4 shows up 3 times, but my least common denominator, I only have to write it one time. Because what's in common in my denominators are x minus 4 3 times, and then the other piece, x minus 5, also exists there. And so a way to check your least common denominator is 2 questions you should ask yourself. Does it include all the pieces that exist in the denominator? If that's the case, then you're good. And does it only include multiple times if they show up once? And so what I mean by that, I only have to write x minus 4 once. I know it shows up 3 times in my denominator in step 1, but I only have to write it once. So this is my least common denominator. From there, I multiply each piece of the equation by my least common denominator. So I go back to step 1. I have a piece here, remember? This is first piece, second piece, third piece. So I multiply my 4, the numerator, by x minus 4, x minus 5, my 3 by x minus 4, x minus 5, and my 1 by x minus 4, x minus 5. It's going to get a little small here. X minus 5. Alright, at that point, I've multiplied each piece of it by the equation. So I am done with step 2a. Step 2b then, at this point, this is where you should check your work. You're going to cancel out like terms in each piece. That's why I need to write it in factored form, because now the canceling out process is really easy. And so, again, this should get rid of all denominators. So if you did this process right, your step 2b should be rewritten to look something like a linear equation with no denominators. So let's see how we did. 2b, if I cancel out my first chunk, 4 over x minus 4, and it's being multiplied by my least common denominator, I have an x minus 4 on top and bottom. So all that I have left in my first chunk is this 4, and it's being multiplied by this x minus 5. So I'm going to rewrite that for my new first chunk. 4 times x minus 5. And then I have an equals sign, so equals. Now, same thing for my second chunk. I have a 3 multiplied by the least common denominator, but in the denominator down here, if you notice, x minus 4 cancel out, x minus 5 cancel out. So I'm just left with this 3. And then I have a plus, so 3 plus. Finally, my last piece, the part 3 up here, piece 3 up here, I have a 1 times my least common denominator. And in this case, the 1's denominator is x minus 4. So all I can cancel out here is the x minus 4 on top and the x minus 4 on bottom. So I'm left with 1 times x minus 5. And if you notice now in step 2b, this should get rid of all denominators, and then I rewrite what's left, so I did that. I did it correctly because I have no more denominators. And if you notice, part 2 of the steps is just multiply numerators if necessary, so I will have to do that here and here, and then solve the remaining linear equation. So I can do that really quick. This part, though, I'm going to not explain as well because it's going to look differently every time, so you're just going to have to call upon your knowledge of solving linear equations. But on the left-hand side, this distributes in 4 times x. I'm going to write part 2 down here. So 4 times x is 4x. 4 times negative 5 is negative 20. Equals my 3 plus 1 times x is just x. 1 times negative 5 is a negative 5 or minus 5. Now I have to put x's on one side, numbers on the other side. There is something I can combine on the right side, so I'll rewrite everything. 4x minus 20 now equals a 3 plus a negative 5 is a negative 2, and then I have a plus x still. So I'm going to put numbers on the right side, so I have to move this 20 over here. If I put numbers on the right side, I'm going to write this in red, I have to put variables on the left side, because I have to balance out the equation. So the x's go away over there, the numbers go away over here. 4x minus x is 3x equals negative 2 plus 20 is a positive 18. And then finally, I divide by 3, divide by 3. So x equals 6. This is the answer to my original rational equation. If I put 6 in for my x's up here, it would balance out the equation and it would equal each other. So go ahead and try part 1 in number 2 down here. So try part 1 in number 2 and then raise your hand. So you should start with a rational equation and your goal is to get rid of the denominators. So you have to get to step 2b. You should cancel out all the denominators. If you need help at any way along the way, please raise your hand because step 2a is very important, finding your least common denominator and then multiplying it with each piece to get rid of the denominator. So after you get to step 2b in number 2, please raise your hand so I can come check your work.